Hello, my name is Jakub Limanowski. I am chair of biological psychology at the University of Greifswald. Biological psychology is basically asking what are the physiological processes underlying our perception and experience and behavior. In my case, my special focus is on body representation and action control. How do we perceive our own body as our own, and how do we know which actions are ours, which sensory consequences in the environment we have produced and which not. And previously that was more or less my topic here at CeTI, where I was a junior research group leader and Freigeist fellow. My research group was called Perception and Human Perception and Action, so a very similar thing with a very specific focus on how these body representations and the neuronal processes underlying these control mechanisms, how they change with cyber-physical interactions with robots or in virtual realities. So of my own projects, these were the fMRI scanning studies, where I had the opportunity to acquire brain scans with virtual reality experiments. Besides those, that must have been either when Stefanie Speidel showed me her medical robots and we were designing an experiment that unfortunately, because I left, never saw the light of day, the experiment. But we were designing an experiment that was a bit more applied, trying to get a grasp on how surgeons might adapt to these conditions where they operate in a telepresence, and was very impressive. And the other things must have been seeing the tactile devices, the data graphs being developed here. We were also, so just seeing the technology develop was exciting in itself. Thinking about these questions, like what's the role of conduction delays or hardware delays in our experimental setups, that was very inspiring. And also just thinking beyond the laboratory, right? Seeing scenarios where you try to get people in daily life to wear sensors or devices or communicate via the internet or operate in telepresence. So this is something where I found it very refreshing to look beyond that and to exchange with people having a completely different angle from robotics or engineers. So one question that has stuck with me is that of delays. How do we humans deal with sensory transmission delays? And those can be in when a virtual avatar moves slightly slower than you expect it to do, or looks slightly different. So all sorts of mismatches. We call this prediction errors, and a lot of my research that I'm doing now is centered on this question of how sensitive are human participants in the lab again to these delays and to these mismatches. What can we do to help them? And then I always have this applied question from CeTI in the back of my head, right? How can we bring this to the real world, beyond the lab, into medical scenarios or daily life? So that has definitely stuck with me. It's all about how do we adapt our internal models, mental models in the brain that we have of what the world is, what our body is, and how we control it. How do we adapt this to the increasing technological changes in society? How do we deal with interactions in social interactions in virtual reality? Or even then, how do we interact with other agents, artificial agents, and how does this depend on sensory processes like delays, as I mentioned, or how does this depend on how these look, how they behave? So that must be, for me, the most interesting question. How does technological advancement change our understanding of ourselves that we have as a person, and then also how that is based on models in the brain potentially. So first advice, doesn't need to be an academic career, but go for it. It's good fun. So there's a lot of advice out there. Mine would probably be start with a problem, not a finding. So what I'm What I'm finding out now is that sometimes I read something that was very exciting, or saw something, and then I tried to come up with an explanation for why this is the case. Probably the better way is to find a problem that you're really interested in, and then see what kind of method do I need to learn, where do I need to go, what do I need to read to address this problem. And I find that having this like bugging problem that you want to solve in the back of your head is really like that's a good motivation for your thesis, for external reviewers, and also for like intrinsically staying with the topic.